Okay, we're going to look at solving the problem x squared plus y squared equals 25 and y equals x plus 1. So this is a simultaneous equation where we're told y is equal to x plus 1 and x squared plus y squared equals 25. So solve this problem to find x and y. So one solution to this, as it's a simultaneous equation, will be to plot both of these two as graphs. And we should recognise that x squared plus y squared equals 25 is the equation of a circle, where we have our x coordinate squared plus our y coordinate squared would give us our radius squared. Y equals x plus 1 we should recognise as it's in our standard straight line linear graph form as a straight line graph with x having a gradient of 1, so we've got 1x, our m is 1, and our y-axis intercept is at 1 as well. So if we were going to sketch the problem, we would hopefully do something roughly like this, and if we were going to plot it exactly, then we could use where these two intersect to find what the solution would be. So we can see from this that the line intersects with the circle at the point 3, 4 and at the point -4, -3. So if we were given an accurate plot of this graph of these two graphs for this problem, we could straight away solve this problem by just looking at the intersections and saying either x equals 3, y equals 4, or x equals -4, y equals -3. Now, if we weren't given this on a graph, we would have to think a bit more cleverly about how we could find the answers there, that x equals 3, y equals 4, or x equals -4, y equals -3. And we'll have a look at how. What we're going to have to do is to solve this using a method called substitution. So, here we have a sketch of this problem now that we could produce. But of course we can't use this sketch to look at what the intersections are because we haven't got that level of detail. So I know that y is equal to x plus 1, and I can use substitution to find out what x would be by, instead of writing y in this equation, x squared plus y squared equals 25, write what I know y is equal to, which is x plus 1. So substituting, if I call that equation 1 and that equation 2, if I substitute x plus 1 from that first equation as y into equation 2, then I'm going to get, instead of x squared plus y squared equals 25, x squared plus x plus 1 squared equals 25. And you might want to just pause the video now and think, well, how am I going to solve this? This still looks quite complicated, doesn't it? So pause and think, how could you now solve this? And then maybe even have a go at it. Alright, well, how we could solve this, if in doubt, expand it out. We should start by just getting rid of this x plus 1 squared. Now it's a really common mistake in maths to think that x plus 1 squared is x squared plus 1 squared. X plus 1 all squared is definitely not the same as that. X plus 1 all squared is the same as x plus 1 times by x plus 1. Which we could say is the same as x squared plus 1x plus 1x plus 1. We could have just written plus x there, couldn't we? And that's x squared plus 2x plus 1. So this here becomes x squared from this part plus, and then this expanded out to become x squared plus 2x plus 1. And we know that's all equal to 25. So how are we going to solve this? Again, you can pause and think about it. We're going to start by grouping together our x squareds, and that will give us 2x squareds. So we've got 2x squared plus 2x plus 1 equals 25. And whenever we've got a quadratic, arguably there are other methods to this, but generally speaking the rule of thumb would be get everything onto one side so you can equate the quadratic to 0, and that's what we're going to do. So if I subtract 25 from both sides, I'm going to have 0 as all that's left on the right hand side, and have 2x squared plus 2x minus 24 equaling 0, as 1 minus 25 is -24. Now we have to solve this quadratic. A little trick might be to divide everything by 2, seeing as 2 is a factor for all of these. So that's what I'm going to do, and then I don't have to worry about the fact that I've got 2x squared. It's always going to be easier to solve using methods like factorising by having only a single x squared, or 1 as the coefficient of x squared. So we're going to have x squared plus x minus 12 is equal to 0. And now we need to have a go at solving this. So we could use the quadratic formula and say a is 1, b is 1, c is negative 12. But we should always really look, when we have a quadratic equal to 0, if it's possible to solve by factorising, as that's going to be a much quicker way to solve. So we should be thinking, are there any fact pairs of negative 12 that are going to add to give me 1x? Well, it's 1x, so add to give me 1. Well, negative 12 and 1 wouldn't work, that would add to give me minus 11. But what about 4 and negative 3? Those are going to multiply as factor pairs to make negative 12, but they're also going to add to give me positive 1. So that's exactly what I want. So I can say that this expression here is the same as x plus 4 multiplied by x minus 3 equaling 0. And remember, you can always just double check your answer whenever you're factorising by expanding out and double checking that you factorise correctly. So if you're not confident on factorising, remember you can always expand out, like we did here, and just double check that you get back to where you started from. It should be that if I expand this, I get this. And you might want to just pause the video and check that yourself. Okay, so we're nearly there. Now we know that we either know that x plus 4 equals 0, or we know that x minus 3 equals 0. Well, that means that x is equal to negative 4, or x is equal to positive 3. And that's the point where a few students make the mistake of stopping. But of course, we were asked to solve this simultaneous equation, which involves not just x, but also y. So if I know that y is equal to x plus 1, then that means that y, when x is negative 4, is going to be negative 4 plus 1. So that would be negative 3. Or y is going to be 3 plus 1, which is 4. So I've just got those y values by substituting what I found x to be back into this top equation. I could have chosen this equation actually. It was much easier to use this equation than it is this equation to find out what y would be. And there we go. So just like before, we found our 3, 4, which is that intersection there, and we found our negative 4, negative 3. Just like we saw right at the start. And that's how you can solve these simultaneous equations involving the equation of a circle by substitution, as well as being able to solve it using an accurate graph. Hope that helps.